Okay, we want to use the intermediate value theorem to show that the function has a real zero between the two numbers given. So what the intermediate value theorem says is if you test 2 points and one's positive and one's negative, there's a zero between it. Because guess what? To get from point A to point B, if you go from positive to negative, you had to cross zero to get there. So it's pretty, commonsensical. But this is something that you're going to be using lots of. It's a favorite theorem of all higher order math, so definitely one we want to spend some time getting familiar with now. So what I'm going to do is I'm just going to do P of 1 and P of 2. So P of 1 here is 4 minus 2 minus 9. So you can see that is 2 minus 9 or negative 7. And then P of 2 is 4 times 4 is 16 minus 4 minus 9. So then I have 16 minus 4 minus 9. And I don't know what I typed into my calculator, but it is not what I was saying as I was talking, is 3. So then we have a positive and negative, so therefore we've shown by the intermediate value theorem there must be a 0 here. Now when it says, so this says P of 1, so it wants you to find them. So what did we just write down? P of 1 is negative 7. It's a good thing I actually wrote these down. Negative 7. Okay. And then this is 3. Is there a value? Yes, because we cross 0. Okay, now the 0 is approximately, so to find the approximation it says use your calculator. All you're going to do is you're going to plug this in to a graphing calculator. So we have 4x squared. So let's see here. 4x squared. Here's my problem going back and forth, right? Minus 2x. I always tell myself I need to write them down, and I seldom remember to do that. Minus 9. So here's our thing, and so you can see here we can approximate. We have a 0 between 1 and 2 here, and I can click on this and get it's 1.77 or 1.8. Let's see what it wants. It wants the nearest hundredth, so 1.77. 1.77. And that's all there is to the intermediate value theorem. So these theorems often look fancy and they've got all this jargon, but really they mostly boil down to very simple common sense points, but by codifying them into theorems, we're able to then use them as building blocks to get to better and more cooler points.